Here we are, and we are going to solve some equations using justifications. Now remember, we're taking these from our properties of equality. A lot of them we don't really use a whole lot when we're solving, like reflexive. We could use the symmetric, but generally we don't need to because it doesn't matter which side is equal to which. Okay, but we look more at the addition property of equality whenever we add the same thing to both sides. Okay. Or we use the subtraction whenever we're subtracting to both sides, and multiplication and division when multiplying and dividing to each side. Okay, or substitution if we have to make a change from one piece to another. Okay, we also, if we really wanted to, could use commutative and associative properties for addition and multiplication, but generally we just kind of do that and say simplify instead. Two others that are very important, the additive identity and multiplicative identity. Okay, we use those all the time. And then there is a possibility of the distributive. Okay, so those are the rules we're using. Okay, so like this example shows us, okay, we had 3x minus 5 equals 15. So they wanted to get x by itself. So x is being multiplied by 3, then subtracted by 6. We do the inverse operation, and we do it in reverse order. So instead of subtracting by 6, we want to get rid of that, so we're going to add 6 to both sides. Okay, that really gives us they probably should have put plus 0 here, because negative 6 plus 6, okay, is going to give us 0. And so it cancels out, but the reason we can get rid of that 0 is what we call that additive identity property. Okay, and then it just gets rid of the 0 and becomes 3x equals 21. So we divide by 3 on both sides because of the division property of equality, and that gives us 1x equals 7. And then that multiplicative identity of 1 allows us to just drop the 1 and we get x equals 7. Okay? So really we mainly use those 6 properties. Those 4 and these 2 are the main ones we use to show that we can create those equivalent equations. Now, we can add or subtract, multiply anything, but we set it up in a way that makes it easier. Okay? So for example, I could add 100 to both sides here, okay, because of that additive property of equality, and I just put ADPO for short. Okay, but does that help me simplify things? Okay. No, that doesn't make my next equivalent equation any simpler. We want to simplify, so we set it up in a way that will simplify it. So I would add 10 to both sides, okay, using the addition property of equality. Negative 10 plus 10 becomes 0, so I have 4x plus 0 equals 2 plus 10 becomes 12. I can drop the 0 because of that additive identity property of 0. Okay. Honestly, I could put additive identity and that would work as well. So then I just drop the plus 0 because that doesn't change anything. Now to separate 4 from x, I'm going to divide by 4 because that'll simplify things. 4 over 4 becomes 1, so I get 1x equals 12 divided by 4 is 3. I can do that because of the division property of equality. Then I can drop that 1 because of the multiplicative identity property of 1. Okay? Those allow me to then get to that simplest form. So again, I've got 1, 2, 3, 4, 5 equivalent equations, but the simplest one is x equals 3, so that's what I'm getting to. Okay? So, and that's kind of what it looks like. So everything follows that same basic pattern. So here, negative 16 equals 3x plus 11. I'm going to subtract 11, because that'll get me 3x plus 0. Okay? So negative 16 minus 11 is going to be negative 27. So I used the subtraction property of equality. Now to get rid of that 0, I use the addition identity of 0. I'll just put the addition ID. Okay, so I get negative 27 equals 3x. So now I divide by 3, giving me negative 9 equals 1x, using the division property of equality. Then that multiplicative identity property of 1 allows me to drop the 1, and I get negative 9 equals x. Now, if I really wanted to, I could also use that symmetric property of equality and make it x equals negative 9, but I don't have to do that. Because that property of equality exists, I know that negative 9 equals x is the same thing. And that gets me, the result I need. Okay, number 3. So 6 minus 2x equals 10. So I need to subtract 6 because it's a positive 6. That gives me 0 minus 2x equals 10 minus 6 is 4. So that's the subtraction property of equality again. And to get rid of the 0, I use that additive identity property of 0. That leaves me with negative 2x equals 4 because that negative stays with the 2. So I'm going to divide by a negative, which I can do because of the division property of equality. That gives me 1x equals 4 divided by negative 2 is negative 2. Then using that multiplicative identity property, I drop the 1 and I get x equals negative 2. And I'm done. Okay, so you see that there's a lot of repetition here. We're using a lot of the same properties to do all this. Okay, so it looks like we got 4 more. Now we've got something that looks a little different. However, I just need to get the x's on the same side. So how do I get rid of an x here? Well, we just subtract an x from both sides. Okay, can I do that? Yeah, because of the subtraction property of equality. Doesn't matter what I add or subtract or multiply or divide, as long as I do it to both sides. Okay, x minus x is 0 plus 18. 6x minus x is 5x plus 3. Okay, again I use that additive identity property. I drop the 0. Then I subtract 3, using again the subtraction property of equality, giving me 5x plus 0 equals 18 minus 3 is 15. Then that additive identity again gives us 5x equals 15. Divide by 5 using the division property of equality. I get 1x equals 3. Then using the multiplicative identity property, that gives me x equals 3, and I'm done. So an extra step or two basically here, but still getting us the same exact result. Okay. Now, looking at 5, kind of the same idea. I can subtract that 2x from both sides, giving me just a 1x minus 10 equals 0 plus 12. Okay, I can drop the 0, giving me 1x minus 10. I can even drop the 1 if I want to, giving me x minus 10 equals 12. Then add 10 to both sides. I get x plus 0 equals 22. Drop the 0, get x equals 22. So I use the subtraction property of equality first. Then dropping the 0 was the additive identity property of 0. Then dropping the 1 was the multiplicative identity property of 1. Then the addition property of equality to get that 10. Then again the additive identity to get rid of the 0. Okay? Alright, 2 more to go. Okay, so number 6, I've got 12x plus 3y equals 15. If you forgot, the instruction said solve the equation for x, so we treat it the same way. So I've got to get rid of that 3y, so I'm going to subtract 3y from both sides. Because of the subtraction property of equality, I can do that. So I get 12x plus 0, because 3y minus 3y is 0. Now, do I know what 15 minus 3y is? It is not 12y. Okay, you got to remember, 15 minus 3y cannot be simplified. So I leave it like that. Then using that additive identity, I end up with 12x equals 15 minus 3y. Okay. Then I divide by 12. and I get 1x equals, now 2 different ways I can do this, okay? And that was the division property of equality. I can leave it as 15 minus 3y over 12, and then using the multiplicative identity, just make it x equals that 15 minus 3y over 12. Okay, so that's one option for me. Okay, the other option is to add one more step here and to actually actually split this up and go 15 over 12 minus 3 over 12, 3y over 12. Well, 15 minus 12 would reduce by 3's and be 5 over 4 minus 1 over 4, so 1y over 4. Which I could write 5 over 4 minus y over 4, okay, would equal x. And for these justifications, I'd write simplify, okay, if we wanted to add it. But I'm fine leaving it that other way, so you can just leave it that way and call it good. Okay, now 7, we could try to distribute, but then that would give us 2 x's. We're trying to get x by itself, so instead we can divide by b plus 7. We can do that because of the division property of equality. It says we can divide by anything. Okay, so that would become 1, so I get 1x equals 9 over b plus 7. So then I just use the multiplicative identity property of 1. I get x equals 9 over b plus 7. Again, I could write simplify. I could go x equals 9 over b plus 9 over 7, but that doesn't really help me out any. Okay, so there we go. That's using these properties, and we can see how they help us solve equations, and that's the reason why we can solve equations like that.